Good morning, everybody. Sorry I can't be here. Today I'm being pulled out for some training, but right now it's time to go over the practice test. This is very important because this practice test is exactly like the test. So if you can do all of these, if you understand all of these answers, then you can do really well on this test. Okay? Now, if I go over all of this and you still have questions, please talk amongst you guys. Ask the sub, maybe he'll allow you to get into groups and talk it out a bit more, and you can rotate or something or whatever. But I do want you guys to understand this material very well. Okay, so let's begin. Number 1, use the CP/CTC to name corresponding parts of triangle, I know it's not printed out correctly, of triangle JKL congruent to triangle PQR. So if we look at this, when they're named, they are already mentioning corresponding parts that J and V will be congruent angles, K and Q will be congruent angles, and L and R will be congruent angles. So if we look here, what angle is congruent to J? Well, J is written up front, so then it must be P. We look at the next one. What is congruent to R? Well, R is in the last position on this second triangle. So if we look at this triangle, it would be the last position here. That would be L. And if we look here, Q matches in the middle, so this would be K. For D, E, and F, you're looking at two letters in the same position. So if we look at JK, it would be PQ. Looking at QR, we see that they're the last two on this one, so then we're looking at KL on the first triangle. And if we look at JL, that's the first and third position, so then we want to say P and R, or PR, not P and R, segment PR. Okay, make sure they're named in that same order too. You want to follow their path. Then, but you really see that happen in number 2. It says complete the congruency statement. So we have triangle, I know it didn't come out, triangle ABC congruent to another triangle. Well, let's see if we can trace this out. A to B to C for my triangle. Okay, let's see if we can trace out that same pattern, right, following the same congruency and arc mark stuff. So this one has no marking on the arc, on the angle. So I'll start on the similar space on this triangle. And then look, on this one, we went along the side that had the first tick mark to the first arc mark. So I will do the same. So I go from E to F and then to D, and that's how I'm going to name it. This triangle is known as EFD. Alright, so there we go with that. Now on to number 3. So then we look here, and it says determine if you can prove the triangles by SSS, SAS, ASA, or AAS, or SAA as it's also known, or HL, hypotenuse leg. If there is not enough information to figure this out, right, not enough information. So let's check these out. So if we look at these two triangles, we have an angle and another angle with the side in between. So to me that looks like ASA. So then if we look at this one, oh look, corresponding parts, right? These two match up, these two match up, and these two match up. Hooray! We have ASA because the corresponding parts of both triangles are congruent. This is ASA. Next we have these two triangles. So if we look here, I have a congruent side, a second congruent side, and a third congruent side. Nice. If I look here, I have a congruent side followed by another congruent side followed by a third congruent side. This is perfect. Right? With all three sides congruent, this is what we call SSS. And lastly here, this side right here, this bottom side, is congruent to itself. It's shared in both triangles. So then if we look between here, these big ones, well, this is not enough information to go off of. You see, if this is a side, you know, that counts for both of the triangles. If we follow the pattern, this is A, S, S. Ooh, make sure you don't touch that. This is not enough information. Oops. Alright, there we go. So then now we're moving on to the proofs. Now the proofs aren't too bad. Okay, these first few ones are actually multiple choice, so that makes things really nice. So when we're looking here, let's try and match up statements. So I look right here and I look at my given, and I make sure that I start off with something from my given. I start off with the first part. So looking here, I immediately recognize, hey, this could be B or E. Right, both of these in this little proof bank here are given. So I can say B or E. Where's the rest of my given stuff? Oh, looking through the proof, oh, here it is. This stuff right here. So then this would be E or B, right? You can only use it once, so it's going to be the other one that you didn't choose for the first one. Alright, then let's look at this. We're trying to prove triangles. Okay, that means if we're trying to prove triangles are congruent, we're going to use one of our hypotheses, or I mean our postulates, my bad. And if we look at that, the only one that fits here would be D, ASA. Alright, so with that, all we have left is A and C. So if you didn't know which one's which, it's a 50-50 shot at this point, so that's pretty good. But if we look at this, we can say, well, this, or this right here, if we look at where this is found, we were told that FAB is congruent to GED. Well, what about these angles right here? This forms a linear pair, right? And all linear pairs are supplementary. So does this one. So we can say that the other angle, BAC and DCE, they are supplementary to the angles that we were given. Or you can say that the angle is a supplement of that angle. So that means this would be A, the definition of supplementary angles. And then, looking here, that would leave one choice left. Congruent supplement, the congruent supplements theorem, which states that if you have two things that are supplementary to congruent angles, then these must also be congruent. And that would make sense, right? If these two are the same measurement, then these two should probably be the same measurement as well. And that's what the congruent supplements theorem says. Alright, so that's that proof filled out. Let's move on to the next. This one is another fill in the blank. So if we look here, one should be really easy right now. Yeah, it's D. It's given. And then if we look at number 7, this should also be really easy. What we're trying to prove should be down here. So looking for it, oh, that's F. And looking down here, well, what would prove that these parts of these triangles are congruent? Oh yeah, that's right. The CP-CTC, corresponding parts of congruent triangles, are congruent. How can we say this? Well, this is going to be because, and yes, that's right, I'm thinking backwards. This is an important skill with proofs. This is because we're proving the triangles are congruent. That's why we can say the parts are congruent, which leads to this solution here. So this would be because of some kind of triangle congruency proof. Oh, right here, ASA. So that would be E. So then all that's left is to figure out some of these. Now I'm just going to work backwards for the fun of it right now. So if I look here, angle 1 is congruent to angle 2. Why? I told you it would haunt you, and it's always going to keep haunting you. They are vertical angles. Okay? This is vertical angles all the time for the win. Okay? Ooh, looking here. Okay, I'm going to skip 4 because 4, since it's using the definition of segment bisector, it looks like it's using something from the previous step. Oh, that previous step says given. Well, what else is given to me besides these parallel lines? Oh, OP bisects segment at LN at M. So that would be right here, G. So that's my other given. And so now they're saying they're taking this bisecting. Okay? OP bisects LN at M. That means if it bisects, that's cutting into 2 equal sections. That means LM and NM are cut into equal parts. They are congruent. That is letter C. And notice, through working backwards, now we only have one answer left, and that would be H. This works though, because since we know LO and PN are parallel, and LN acts as a transversal. So then we have alternate interior angles, right? Chapter 3, make sure you know those. They pop up a lot. For triangles especially though, it's usually just this, the alternate interior angles. Alright? So I hope you're not having too much trouble with these. Let's move forward. Number 6. Number 6, this time we have to start filling it out on our own. So let's work it through. Okay, so I'm going to start backwards just for fun. Whoa, F is the midpoint of LO. Okay, so I don't know that definition. But what I do know is that to get to this part, well, I'm going to look ahead. Number 6, I have triangles that are congruent. So that means I'm going to use one of my triangle postulates here. That means right here, I'm guessing I'm going to need to use the CPCTC to show that some parts are congruent. Now, if I'm looking at LO, that's this length here, and F is at the center of this, so I'm probably, if F is the midpoint of these two, that would mean that these two are congruent. Okay, so then that must mean that that's what my CPCTC is trying to prove, right? If this is my midpoint, these two lines are congruent, so that's what my CPCTC is going to try and prove. It's going to take these, saying that these triangles are congruent, and then that those sides, LO, I don't have time to put the little mark above it. I apologize for my lack of what just happened? For my lack of being able to use all the correct math symbols at the moment. No, not LO. LF is congruent to OF. So we know this now. That's good. So then, because these are congruent, now we're saying that F is the midpoint since they both share F. Well, that's the definition of midpoint, of a midpoint. So now we need to go through the rest of these and figure them out. Okay? Right now this video is about to time out, so I'm going to cut it here. Please, substitute teacher, I would mind it if you would hit the second part of this video. The link will also be on the desktop. Okay? Alright, thank you.